So chapter 6.4 talks about the domain of the logarithmic function. And an important thing to note is that we know that the log function is the inverse of the exponential function. So since we've seen that for exponential functions, the domain is all real numbers, then we know that the range of the log function is going to be all real numbers since it's the inverse. And that the parent function for the exponential graph has a range of 0 to infinity, so that's going to be the domain for the log graph. And these are our parent functions. So let's say that f of x equals log base b of x is our original parent function. Then our transformed graph is g of x, and is going to be some vertical compression or stretch a times log base b of x, and then here's our horizontal shift and here's our vertical shift. So the only thing that's really going to change the domain is what's in here, because we know that the domain is restricted by values of x that if you plug them in, they yield values, y values that are undefined. So if there's any vertical reflections or vertical translations, that actually does not affect our domain. So part A gives us f of x equals log base b of x minus 7. And we know that we cannot take the log of any x value that is less than or equal to 0, because then it's going to give us an undefined y value. So if we take this whole expression, x minus 7, and set that greater than 0, then we can find where this function is actually defined. So if we add 7 to both sides, then we get x is greater than 7, and that's our domain for the first part. Alternatively, we also know that the default domain for the parent function is 0 to infinity. And we know that this whole graph is being transformed. It's being shifted to the right 7 units. So our new domain is going to be from 7 to infinity. So part B gives us g of x equals log of 2x plus 3. And it's going to be the same concept. We're going to take this expression, 2x plus 3, and set it greater than 0. So if we solve for x, we get that x is greater than negative 3 halves. So our domain is going to be negative 3 halves to infinity. And that also means that our vertical asymptote is going to be at x equals negative 3 halves. And then the one for part A is going to be x equals positive 7. And the last part, h of x, is negative natural log of 2x plus 12 minus 5. So we have a vertical reflection and also a vertical translation, which is not going to affect our domain or our vertical asymptote. So what we're going to do is the same thing, take this inside, 2x plus 12, and set this greater than 0. And then if we solve, then x is greater than negative 6. So our domain is going to be negative 6 to infinity, and our vertical asymptote is going to be x equals negative 6.